Welcome to another video. Today we are going to talk still about linear equations, but now we want to focus on writing them in point-slope form. And for this, today we're going to be given a slope and a point. Again, we want to show mastery by scoring at least 80% on that exit ticket in class. Make sure you have your notes. I know they're only a half sheet today. These are a little bit smaller problems, so we don't need as much room. The biggest thing that you need to keep in mind when it comes to point-slope form is this formula. And again, it is posted in the classroom, so if during class at any time you do forget, it is there to help remind you, but make sure you have that formula. When we say y, there's no subscript of a number, so it is just y. It is like y equals mx plus b. It is any point. Same thing with x. If it has the subscript of 1, those are the variables that we want to fill in. You're going to start by writing that equation, and then we need to identify what our m, x1, and y1 are. It's really important to identify before we start plugging numbers in because it's very easy to make a mistake. However, identifying those points, it'll make your life a lot easier and less likely to make that mistake. Then we're going to solve, and we're going to get an equation in slope-intercept form. If we look at our first example, we already have our m in the problem. M is equal to -8. If I look at the point -4, 6, -4 is my x, so I'm going to call that x1, and 6 is my y1, just like when we labeled points for slope. Now, my point-slope form is y1 minus y1 equals m times x minus x1. So now I'm just going to substitute my numbers in. Y doesn't have a subscript, so I'm going to keep that in, minus my y1 is 6. That equals m is -8. X doesn't have a subscript, so it stays, minus, and in this case, -4. Now, we know from class that a negative and a negative make a positive, so I'm going to make this x plus 4. From here, we want to solve for slope-intercept form. And just as a reminder, in case you forgot, although by now we've used it enough, I'm sure you have it memorized, y equals mx plus b. First thing I want to do is distribute. So I have y minus 6 equals -8x. A -8 times a positive 4 is a -32. I'm almost done, but y still has this minus 6 next to it. So the opposite would be to add 6 on both sides. When I do that, I'm left with y equals -8x minus 26. Now I have my slope-intercept form. And if I were to ask, -8 is my slope, or my m, and -26 is my y-intercept, or my b. This is as far as we go. We don't have to graph these. We'll get to that later. But we would graph it the same way we've been graphing both the standard form and the slope-intercept form. Use your y-intercept and use your slope. If we look at our second example, again, m is given to us, so that's fairly simple. I'm going to call 3 my x1 and -2 my y1. My equation again, y minus y1 equals m, x minus x1. And yes, I do want you to write the equation down each time. This eliminates some of the error because you're going to have the equation right in front of you. You're not going to be trying to recall it from memory. And the more you do it now, the more it'll be second nature on the test. You won't have to think about it. You'll know exactly what the equation is and be confident in your answer. Now I'm going to fill it in. I have y minus -2 equals -4 x minus 3. Again, two negatives make a positive. So y plus 2 equals -4 times x minus 3. I'm going to distribute my -4, and I get y plus 2 equals -4x. -4 and -3 give me positive 12. I'm not done because y is not by itself, so I'm going to subtract 2 on both sides. Now I have y equals -4x plus 10, where -4 is my m and positive 10 is my b. Again, I'm not worried about graphing them, but if we needed to, we very well could. In our third example, our slope is a fraction, but that's okay. because fractions are our friends, so we're going to keep using it. My x1 is -5, and my y1 is -1. So my equation, y minus y1 equals m times x minus x1. So if I substitute in, I have y minus -1 equals -5/4 x minus -5. Well, on both sides, two negatives make a positive, so we now have y plus 1 equals -5/4 x. A negative and a negative make a positive, so we get plus 5. From here, we want to distribute. We end up with y plus 1 equals -5/4x. Remember, when we do -5/4 times 5, you want to multiply the top and divide by the bottom. So I end up with -25/4. We can't reduce the fractions, so we're going to leave it like that. I know it's not the prettiest, but it works. I still need to get y by itself, so I'm going to subtract 1 on both sides. I'm now left with -5/4x. In this case, this is like subtracting 4/4. And if you weren't sure, please plug it into your calculator. We have these nice calculators. They do all the hard stuff for us, so plug it in. We end up with -29/4. I'm now in y equals mx plus b, and my m is -5/4, and my b is -29/4. Now, that is a little challenging to graph in the sense of it doesn't fall exactly at an intersection point, but if we needed to, we could identify a graph with that. Our last example, I have point-slope form. Now I just need to turn it into slope-intercept form. So, my first step, we're going to take and we're going to distribute. So, y plus 2 equals -3x. A -3 times a -1 is a positive 3. Subtracting 2 on both sides gets my variable y by itself, and I'm left with y equals -3x plus 1, where -3 is my m plus 1 is my b, or my y-intercept. Those are all the examples I have for you today. If you need to re-watch, please feel free to do so. If you feel comfortable enough, flip to the back. There are a couple examples on the back. Complete them and bring them into class tomorrow. I look forward to seeing you then.